So let's dive a bit deeper into thermal expansion, a simplified atomic picture. So why material changes size when we heat or with temperature, with increase in temperature or decrease in temperature? The thing is, atoms are always vibrating. It includes your solid, liquid and gases. They are made up of atoms, and these particles are never still. They constantly vibrate or move. So higher the temperature, higher the kinetic energy of the atoms. So when we heat, right, heating increases atomic vibration. When temperature increases, atom vibrates faster. Vibration have larger amplitude. This increasing motion pushes the atoms slightly further apart. That's the basic idea. So you have a particle, right? And in general, actually I do have, just a second, let me show it here itself. Okay, so we have this particle, ignore the arrow. So this is basically how it would be. So if I increase the temperature, you can see that it's vibrating more. That's the whole funda. Okay, yes. So that's what we are trying to, yeah. That's what we have written over here. Now, interatomic forces are not symmetrical. So this is one point that we'll be diving in detail, but let's look at it. Let's start with first step. Atoms are bound by attractive and repulsive forces. The potential energy curve of the bonding is asymmetry. So you can see symmetrical would be something like this. Let me show that as well. Symmetrical is this. Okay, this is symmetrical, right? Your second grade, third grade syllabus. So if I fold the paper along this line, these two lines will overlap. This curve will overlap. So that makes it symmetrical. But here you can see that it's asymmetrical. So stronger repulsion when atom gets closer and gentle attraction as and when the atom gets far away. Because of this asymmetry, larger vibration shifts the average spacing outward. So this is a part of a theorem. So we'll be looking into this directly. All you have to know is, as and when the temperature increases, right, atoms tend to be far away than close by. That's the whole funda. As a result, the material expands. The increased average spacing between atoms increases in dimension. In solid, atom does not change the position, but the spacing increases. While in liquid, the molecules move further apart. While in gases, molecules move faster. Okay, at constant pressure and volume. So at constant pressure, the volume increases a lot. So cooling causes the opposite effect. It contracts. There's decrease in vibration and so on and so forth. Key insight is expansion is not atoms getting bigger, right? There's a misconception. People feel that expansion, when we tell on increase in temperature, the object size increases per se at atomic level. Atoms themselves are not increasing in size. Their radius and energy levels are not changing. If you go to the next chemistry chapter, right, atoms have fixed radius and the outer shell and inner shell and so on and so forth, right? The outer shell is not per se increasing, you know. So that radius is not increasing. That sphere is not increasing. What is increasing is the space in which the molecules and the atoms move. So expansion is actually atoms staying the same size but moving further apart due to increasing energy. They have more energy to move around. So real life example, gaps in railway track are needed for safety purpose, and if not, you can web search what happens. Sagging of power wire in summer, all of this you guys can have a look. Bimetallic strip. So that I'll be showing you guys, bimetallic strip. So that is one thing that I'll be showing. If not, yeah, this is a small introduction again. In detail, we'll be looking at this. Each of this actually.